Hello everyone. Today we're going to do some indifference of functions, and it's where we're going to take two functions. We could do more, but we're going to take two and we're going to add them, which is a sum, or we're going to subtract them, which is a difference. Okay, so we're just going to go through a little summary first here, and then we'll go through and we will do some questions. So I can ask you to find h of x equals f of x plus g of x. Okay, you're going to immediately rewrite that like this. H of x equals f of x plus g of x. So you're literally just going to take the two functions and add them. So we're going to take f of x, which is x squared, and g of x, which is negative x plus 5. And we're going to rewrite the equation. H of x equals f of x plus g of x. And in for f of x, we're going to put x squared because that's what it equals. Plus in for g of x, we're going to put negative x plus 5. And we collect like terms, we get x squared minus x plus 5. Okay? Down here it shows the two graphs. If I take the f of x graph, which is x squared, which is this, and I add it to the g of x graph, which is the line negative x plus 5. When I add those two, I'm going to get my third graph, which is f plus g, which is that x squared minus x plus 5 graph. Okay? Similarly, I can do subtraction. With subtraction, I can go h of x equals f of x, f minus g of x. It can be written like this. If it is written like this, you're going to rewrite it as h of x equals f of x minus g of x every single time, because the other version doesn't really make a heck of a lot of sense. F of x, in this case, is negative 2x. Okay, negative 2x is actually this gray graph. It's not labeled well. So that's f of x. G of x is x minus 4. So that's going to be, we'll make it pink, this graph. Okay? All right. So if I go f of x minus g of x, I have to go negative 2x minus x minus 4. But do you see here how there are brackets around here? This is where everyone errs in the subtraction one, okay? In the difference. They're going to err here because you're going to forget to subtract the whole function, which means you have to put in brackets and then distribute. So there's another step in here. My goodness, I just keep making these lines by accident. Okay, so another step in here is you're going to do negative 2x minus, and now you have to distribute into this bracket, minus x plus 4. So if you forget those brackets, you're going to forget to do that other term and subtract it as well and not get the plus 4. So do you see here when we collect negative 3x minus 1 or negative 2x minus 1, we get negative 3x plus 4, and that gives us the third line. And that gives us this one right here. I use blue, you can't really tell the difference, but it gets us this line here. Okay? So this is a little summary. Now, you can only add and subtract functions where both functions exist. So here it says the domain of the combined function formed by the sum or difference of two functions is the domain of the that's common to the individual functions. So if you look at both of these functions, both the f and the g in both equations, or both examples, they both have domains of XER. Both equations. So the combined function is going to have one of XER. Okay? If the domain of f of x is greater than or equal to 0, and the domain of g of x is less than or equal to 10, then the domain of the combined function, so f plus g, is where they both exist. So between 0 and between 0 and 10, so greater than 0 and less than 10. So an example could be, if I sketched that graph, sorry, this is going to be messy because it's awesome. My drawing is awesome. I'm going to get some lines so those are not so messy. All right, boom, one line. Boom, another line. Let's move that baby. Okay, that's still a little crooky. June. There we go. Okay, so if I have a potential graph, it could look like whatever. I'm going to make it pink. So up here it says f of x is greater than or equal to 0. So let's pretend this is f of x. So it's a radical function, right? And then let's pretend g of x is another radical function, but it is less than or equal to 10. So it's been reflected. So that's 0. We're going to pretend this is 10. And now it's going to be less than or equal to 10. Boom. There, that's my g of x. I can only find these two graphs where they both exist. So the domain where these graphs both exist starts at 0. Look here, that's where they overlap. Here is at 0. Wow, that's terrible. And then here is at 10, and then in between those two values, right? That's where both graphs exist. So that's why the domain for this one, the combined function, adding or subtracting, is going to be from 0 is less than or equal to x is less than or equal to 10. And the 0 and the 10 are included because the graph is actually, both graphs are at 0 and at 10 and in between. So you don't actually even have to, if they ask you for the domain, you don't even have to draw the graphs. You just have to see where they both exist. Okay, so we're going to move on. So let's look at example 1. Example 1 states that f of x equals 3x minus 2 and g of x equals 2x plus 1. Determine the equation of the combined function. So we want f of x plus g of x. Okay, so I'm going to scroll this up. F of x plus g of x is going to equal 3x minus 2 plus 2x plus 1. Now, if I did g of x plus f of x, it wouldn't change it. I would get the exact same one. So if I have the order wrong with f of x plus g of x or g of x plus f of x, I will get the same equation. However, subtraction, it's different, because with subtraction, if you subtract them the wrong way, you're going to negate the wrong equation. So addition, we have 3x minus 2 plus 2x plus 1. I don't need brackets. If I wanted to, I could put a bracket like I did in the other one. But when I distribute a positive 1 in, it doesn't change it. So I don't really need that bracket. So if you don't want to write it, you don't have to. So I'm going to have 3x minus 2 plus 2x plus 1. Sorry, my kindergarten handwriting is not getting better. If I use my tablet, it looks quite terrible. So here we're going to collect like terms. I'm going to go 3x plus 2x, which is 5x. And then we're going to do negative 2 plus 1, which is negative 1. So this is our combined function, 5x minus 1. So if I take the equation fx and I add g of x, I'm going to get a new equation, which is a line at 5x minus 1. So when I add two lines, I end up with a line. Isn't that cool? I know, you're enthralled, right? So now we're going to do f of x minus g of x. This makes a difference if I do g of x minus f of x. I'm going to subtract the wrong one. So you have to make sure that you put them in the correct order. So f of x is 3x minus 2 minus g of x. And here's where the error lies. People just write the equation like they do with addition. That is not okay. You need to make sure that you subtract all of g of x. So you have to put it in brackets. Okay? So I'm going to rewrite it. I'm going to get 3x minus 2. And then I have to remember to distribute. And if you forget this, you're going to get every subtraction question wrong every single time. So I'm going to go minus 2x minus 1. So once I'm done distributing, I have no brackets left. So now I can collect like terms. So I'm going to get 3x minus 2x, which is x. And then I'm going to get negative 2 minus 1, which is negative 3. So if I take the two functions and I add them, I get the equation 5x minus 1, and I could draw that graph. If I get the two equations and I subtract them, I'm going to get x minus 3. Okay? Now you can check with your calculator each time, but you're going to have to show algebra anyway, so I can show you I can tell you about the calculator way. You can check these with your calculator, because in y1, you could technically, for a, f of x plus g of x, in y1 you could type 3x minus 2 plus 2x minus 1 into your y1. And then in y2 you could type your answer, 5x minus 1, and they should be the same graph. If they're not, you made a mistake. So for b, I could type into my y1 in my calculator just to check. I could type 3x minus 2 minus 2x plus 1. But I would have to make sure that I put that g in brackets. And I use minus signs, not negative signs, because these are minus signs. People use negative signs by accident and it messes them up. And then in y2, I could type my answer, x minus 3. And I should get the same graph. If I don't, I made a mistake somewhere. Okay? So you can check these with your calculator. Now we're going to try this last one. It's g minus f of 2 this time, though. So remember, if it's written weird like this, we are going to rewrite it as separate. So g of 2 minus f of 2. Now in grade 10, we were taught to deal with function notation, g of 2 and f of 2. All that meant, and we're going to do this off to the side, is that I need to find out, and I do these off to the side all the time. I don't do them in my equation. I show my work off to the side. I need to find out what g of 2 equals. Whenever you have something, a number in a bracket, that just means that's what x is in the equation. So g of 2 is 2x, g of x, is 2x plus 1. So g of 2 is going to be 2, and instead of x, I'm going to put a 2 in for every x. That's what this means. So g of x is 2x plus 1. I'm going to get 2 bracket 2 plus 1. So I get 4 plus 1, which is 5. So I can go back here and I can go g of 2 is 5. Then minus sign. Now I need to find f of 2. I'm going to do that off to the side. So f of 2, all I'm going to do is fill 2 in for the x's and f. F is 3x minus 2. So I'm going to go 3 times 2 minus 2. So I'm going to get 6 minus 2, which is 4. So now over here I can go minus 4. And 5 minus 4 is 1. So technically, when I fill a value in for x like that, I actually found a new point on the graph of g minus f. So on the graph of g minus, I'm just going to explain this. On the graph of g minus f of x, so g of x minus f of x, on this graph, I have the coordinate 2, 2 is my x because I used it for both my x's, 2, and my y is my answer, 1. So when I fill a number in for x, I'm actually just finding a coordinate on the graph of the two combined functions. Okay? So we can do that. We can just come up with new equations or come up with a point off of a graph of the combined functions. Or example 2, it says let f of x equal 5x squared and g of x equal the square root of x minus 3. So it's from radicals from the last unit we were doing. Determine each combined function and state its domain. So we want, oh my goodness, I keep doing that. It's when I go to make my screen bigger, I accidentally draw. Sorry. Okay, so we're going to do y equals f plus g of x. I told you the very first thing we're going to do, though, is rewrite it. So we're going to do f of x plus g of x. And then we can rewrite it now. So we're going to get y equals f of x is 5x squared plus g of x, which is square root x minus 3. Okay? Good. You can't actually simplify it anymore. That's the answer to the equation added. The domain, however, is where the two graphs exist. Okay, so when I add functions, subtract functions, if I look at where the two graphs exist, I will actually have their domain. So an x squared graph, a 5x squared graph, actually is XER because it's quadratic. Quadratic has domains of XER. That's for this one. A radical graph, however, remember there's values that don't exist because you'd get a negative under it. So remember I told you when you have a linear under a radical, you just say x minus 3 has to be greater than or equal to 0. It has to be in order for it to be under that radical symbol. And then you move that minus 3 over by adding it, so x has to be greater than or equal to 3. So we really have a graph that's at 3 and going like this way. And we're going to add and subtract those graphs. Well, where do both those graphs exist? 3 and further, right? That's where those graphs exist, at x equals 3 and greater. So our domain for every single one of these, a, b, and c, because I'm just adding and subtracting the two functions, is going to be greater than or equal to 3, because that's the only place that both of these graphs exist. So that's the good thing about the domain. It's really easy to find. So once I found it for adding, subtracting, it's going to be the same, because for the domain only exists where the graphs, both graphs exist. So for this one, it's going to be squiggly brackets x, such that x has to be greater than or equal to 3 xer. Or in interval notation, that's 3 to infinity. My b is f minus g of x. My c is g minus f of x. So I'm just adding and subtracting. So to be honest, my domain isn't going to change. My domain is going to be x is greater than or equal to 3 xer. Ooh, that's a bad 3. Or in interval notation, this. In set notation, it's the same. So the domain is not hard once you find it for 1. For adding or subtracting, it's going to be the same, because you can only find where the two graphs exist. Okay, so when you're looking for the domain, please look at the domain of each function separately and then figure out where they both exist, and that's the domain of the combined sum and difference functions. Okay, let's do f minus g together. So we have f minus g of x, so the first thing we're going to do is rewrite that as f of x minus g of x. Now I have to do it in the order that is. So I have to do f of x, which is 5x squared, minus g of x, which is square root x minus 3. Okay? Now I don't distribute the negative in because that's a radical. You can't distribute it inside the radical. You're done. That's the equation of f minus g. Now you're going to try to do g minus f. So pause it and try g minus f. Okay. I hope you tried it. So g minus f, I'm going to rewrite it as g of x minus f of x, because that's what I do immediately if they're both in brackets. And so y equals g of x this time is square root x minus 3 minus 5x squared. Now, why did I not put the 5x squared in brackets? Because it's only one term. Why did I not put the x minus 3 in the previous equation in brackets? Because it's just one term. So I have to remember to distribute the subtraction sign if the second equation that I'm subtracting is more than one term. Okay, so I'm done. Y equals square root x minus 3 minus 5x squared. I can't collect like terms. But it is totally different than B's equation. So you have to do them in the order that they are given to you. Okay. So example 1, I gave you functions where you just had to come up with the equation or a point on the graph. Example 2, I gave you functions where you had to come up with addition of functions, subtraction of functions, and their domain. Example 3, use the graph of f of x and g of x to evaluate the following. So f plus g of negative 5. So the very first thing I'm going to do is I'm going to rewrite that. F of negative 5 plus g of negative 5. Now up top, I plugged the negative, I would have plugged the up here for 1c. I plugged 2 into the equation, g of 2, and I plugged 2 into the equation of f, and I got f of 2. Well, here, this is even easier. Although people find these harder, they're easier. They gave you the y values. You just have to find them off the graph. So I need to find f of negative 5. So I go to negative 5 on the x. I follow it up to f. And f of negative 5, and I look for its y value that correlates, is 3. See? So at f of negative 5, my y value is 3. So I put a 3 in here. G of negative 5, I'm going to go to negative 5. I'm going to follow it up to G. And I'm going to follow it over. And it's 6. So I get 3 plus 6, which is 9. So on the graph of f of x plus g of x, this is what I just found. When I plug in an actual value for x, on the graph of f of x plus g of x, I have a new coordinate at negative 5, because that's the x I filled in, and 9. So I just found a coordinate. I didn't find the entire graph of f of x plus g of x. I found a coordinate, negative 5 and 9. Okay, let's do it for b. b is f minus g of 3. So I'm going to rewrite it as f of 3 minus g of 3. So now I'm going to go to 3, and I'm going to follow it up to f. And then I follow it over. So at f of 3, my y is 1. No. Okay, at f of 3, my y is 1 minus g of 3 so I go to 3 and I follow it up to g. See, g is labeled as this one. So I follow it up to g and I follow it over, and it's 2. So 1 minus 2 is negative 1. So what did I just find? F minus g of 3. Okay, I found a coordinate on the f minus g graph. It's at 3 and negative 1. Cool, hey? All right. I'm not going to lie to you, doing podcasts with no one in front of you is like super boring. You know you sound boring. I'm so sorry. But you get what you get and you don't get upset. It's so much easier to teach in front of a class. And we all miss you guys so much. We wish we could see your faces, and we wish we could ask questions, and we wish we could just even talk to people. So I'm sorry, this is boring, but it is what it is. So I'm going to get you to try C and try D. So you're going to pause and try those. Okay, so I hope you did. So we're going to have G of 4 minus f of 4. So this time, I'm going to go to 4. I hope you did this on your own. So g of 4 is the first one I'm going to go to. So I'm going to go to 4, follow it up to g, follow it over, and my y is 3. Minus, then I'm going to do f. I go to 4, I follow it up. It's actually on the x-axis, so it's 0. 3 minus 0 is 3. So what did I find? I found a coordinate on the graph of g of x minus f of x, and that coordinate is at 4 and 3. That's what I found. Okay, I hope you tried this one too. So f plus g of 0 is just f of 0 plus g of 0. So I go to f of 0. So I'm going to go to 0 and follow it up to f. It's at 2. So f of 0 is 2 plus g of 0. Whoop, did it again. It's so annoying. Okay, and then I go to g, 0, follow it up. It's at 1. So I get 2 plus 1, which is 3. So on the graph of f of plus g of x, I have a coordinate at 0 and 3. Now, explain why f plus g of 5 cannot be evaluated. So that's f of 5 plus g of 5. Okay, let's try and find it. So, f of 5, let's do first. F of 5, f doesn't exist at 5. G exists at 5. G at 5 is 4, so that's great. G of 5 is 4. But there's no answer I can put in for f of 5 because f of 5 does not exist. So explain why f plus g of 5 cannot be evaluated. because the f of x graph does not exist at x equals 5. Or you could say the domain of f of x is less than or equal to 4. That would work as well. So that would be another reason. So what is the domain of f of plus g of x and f minus g of x? Remember, if it's adding or subtracting, they have the same domain. The domain is where the two graphs both exist. Well, f of x starts at 4 and goes to negative infinity, or negative infinity to 4 technically, and g of x has a domain of xer. So these graphs actually both start at 4 and then they both go this direction, right? There is no f on this side, so this does not exist. So the domain starts at 4, well, it starts at infinity and goes till 4 technically, right? That's where both graphs exist. So where is the domain when I add them or subtract them? The domain is going to be at x such that x is less than or equal to 4 xer. Or in interval notation, negative infinity to 4. Square bracket because it's equal to. So this is set notation up here with the squiggly brackets and interval notation with the square brackets. Okay, then example 4, what I could do. For example 4, I could ask you to actually come up with a new graph, but only giving you two graphs, no lines, no equations, I mean. So remember, I can only compare graphs where they both exist. So this is going to be, add a sketch of the combined function indicated to each graph. So y equals f plus g of x. So I'm going to do f of x. Ooh, my chicken scratch is something else. This is so annoying. I hate being messy. Ah, I did it again. Oh gosh, really? Okay. Equals f of x plus g of x. Just so you know, I try and record with a smile on my face because I feel like when you record without a smile on your face, you just sound angry. And I actually love math, so I'm not angry. So, okay. How are we going to find the new graph? Well, we've learned how to find points on the new graph by just plugging in the same x value, right? So we can do that. So if I plugged in -1 for my x's, I would be in trouble because f of -1 is like down here off the graph. So I can't use -1. I can't do -2, -3, -4. The graphs do exist that direction because there are arrows. So g of x has a domain of xer and f of x has a domain of xer. So the combined function is going to have a domain of xer, but I can't literally find that point at -1 because the graph of f of x doesn't have one. So I have to start at 0 because that's where the two graphs actually have points. So if I do the combined function, if I do f of 0 plus g of 0, I have to use the same x's in order to find my new coordinates y. So f of 0 is at -5 plus g of 0 is at 0. So I have -5 as my answer because -5 plus 0 is -5. So on my new graph, I'm going to have the coordinate 0 and -5. And I'm going to plot them after. So that's one coordinate. Then I'm going to do 1. Could I do 0.5? Sure. But I'm not going to. So f of 1 plus g of 1. So f at 1 has a y value of -2, and g of 1 actually has a y value of -2. So I'm going to do -2 plus -2. Oh my goodness, my pen wasn't working. Work. -2 equals, don't fail me now, marker, or pen, or whatever, stylus, -4. Oh my goodness. Why? Okay. So my answer is -4. So my x that I shared for both of them was 1. And my y is -4. So that's another new point on the f plus g of x graph. And I'm going to do 2, the number 2. F of 2 plus g of 2. F of 2 is 1 plus g of 2 is negative 4. 1 plus negative 4 is negative 3. So a new point on my new graph is going to be at 2 because that's my x's that I used, and negative 3. Oh my goodness, my stylus isn't working. 2 and negative 3. I love technology. Nat. Okay, so that's my other new point. And then I'm going to do one last point. F of 3 plus g of 3. So f of 3 is at 4. G of 3 is at negative 6. And so I get negative 2. So my new point's at 3 and negative 2. Now I could keep going to 4. The problem is that I can't see f at 4. I'd have to just guess it, and I don't want to guess it. So I'm going to stop there. So I have 4 coordinates on my new f plus g graph. So I'm going to erase these ones off, and I'm going to plot those, and then I'll have the new f plus g graph. So I go 0 and negative 5 is my 1 point. 1 and negative 4 is my next point. 2 and negative 3, 3 and negative 2, and arrows out because the domain of both of them is XER. And that green graph I'm going to label as f plus g of x because that's my new graph. And you're going to try B. Okay? And pause it, and then you can check and see if you got it right. Okay, so for B, I have f of x minus g of x. So I have to do it in that order. Now they're both XER graphs domains, so my graph is going to, my new f minus g graph is going to actually have a domain of XER. All right, so I am going to start where they both start, which is at negative 4. So I can do f of negative 4 minus g of negative 4. I have no idea if you can hear my girls screaming. They are excited about something, and I'm podcasting at home. And I have 2 little girls who are 6 and 9, and sorry if you can hear them, but they're super excited about something. Okay, so f of negative 4 is at 8 minus g of negative 4, which is at 4. 8 minus 4 is 4. So I have a new coordinate at negative 4 and 4. Man, the stylus is making me so happy because it's not working. It's not making me happy. Okay. Okay, so then we're going to do, we could do f of 3. F of negative 3 minus g of negative 3. So f of negative 3 is at 4.5, it looks like. Minus g of negative 3 is at 3. And it's 1.5. I've now figured out what they were super excited about. Cereal. They're super excited about cereal. We have turned into a life where cereal brings excitement. I guess. That's what happens when you're locked indoors. Okay. F of negative 2 minus g of negative 2. They're both at 2. So 2 minus 2 equals 0. Yeah? And so we get 0. So we have negative 2 and 0. And then if we do f of negative 1 minus g of negative 1, f of negative 1 is at 0.5 minus g of negative 1, which is at 1. And then we're going to get negative 0.5. And we're just going to keep doing that. F of 0 minus g of 0. F of 0 and g of 0 are zeros. So I'm going to get 0 minus 0, which is 0. So I have coordinate 0, 0. So I'm going to sketch that half. Whoa, I meant to press the eraser. Okay, so I have negative 4 and 4. And then I have negative 3 and 1.5. And then I have negative 2 and 0. Negative 1 and negative 0.5, so down here. 0, 0. And when I do the other side, I'd have to keep going. I'd have to plug in f of 1, which I actually get negative 0.5 for. F of 2, I'm going to get 0. F of 3, I'm going to get 1.5. F of 4, I end up getting this. So I end up getting something that looks like a weird W. Like that. And it has arrows on the edge because the original is XER, so the combined is XER. So you literally have to show all that work along it to get your new function. Okay. Now I could add or subtract more than one function. So here I have f of x minus g of x minus h of x is what I'm going to do for example 5a. F of x is 2x plus 3, g of x is negative x squared plus 5, h of x is negative x. Determine each combined function. So we want f of x minus g of x minus h of x. So we're going to do y equals f of x, which is 2x, minus g of x, which is x negative x squared, plus 5. But we have to remember to put it in brackets. And then minus h of x, which is negative x. But we have to remember to put it in brackets. So I'm going to get 2x minus a minus x squared, so plus x squared, minus positive 5, so minus 5, minus a minus x squared, so plus x squared. And then my last step is to collect like terms. So x squared plus x squared is 2x squared. 2x, so plus 2x, minus 5. All right, you're going to try B. So first off, you're going to find k of x equals h plus f minus g of x, and then you can plug in the negative 1. So we're going to do k of x. You can pause it and try it yourself. K of x equals h of x plus f of x minus g of x. So we're going to get h of x, which is minus. So k of x equals minus x plus f of x, which is 2x plus 3, minus g of x, which is negative x squared plus 5. So we're going to get negative x plus 2x plus 3. That is supposed to be a 3. It does not look like it. And then minus a minus x squared, so plus x squared. And then minus 5, so you get a minus 5. So do not forget the brackets. So we're going to get k of x equals, collect like terms, x squared minus x plus 2x is plus x, plus 3 minus 5 is minus 2. And then we can find k of negative 1. equals -1 squared plus -1 minus 2. -1 squared is 1. Minus 1 minus 2 is actually -2. So I found a coordinate on the k of x graph. That's technically when you plug in for x, you found a coordinate. That coordinate is at -1 and -2. Now you don't have to state this each time. I just want you to know that when you are plugging in a value for x into that function, you literally are finding a coordinate on its graph. Weird, I put a line instead of squishing it. All right. We have the function example 6. Now this lesson is longer than the other lessons just because I really wanted you to wrap around how you do the functions when you're doing operations on them, how you can find graphs from a graph, how you can find points from a graph, how you can find points from a line. So this lesson is actually quite long. Okay. So example 6, if h of x equals f plus g of x and f of x equals 4x minus 7, determine g. So this time, you're actually given the answer, the completed graph, when you add the two. Okay? So we can still plug that in. So we rewrite our equation. H of x equals f of x plus g of x. H of x is x squared minus 2x equals 4x minus 7 plus g of x. And now I need to just get g of x by itself. How do I do that? I subtract 4x and add 7. Subtract 4x, add 7. So now I have x squared minus 4x minus 2x, so minus 6x plus 7 equals g of x. And then you get to try this one, h of x. So you can pause it and try it. H of x equals f of x plus g of x. So h of x is negative 2x squared plus x plus 1 equals f of x, which is 4x minus 7, plus g of x. And then you're going to minus 4x plus 7, like we did before. Minus 4x plus 7. So we're going to get g of x equals negative 2x squared. X minus 4x is minus 3x plus 8. And then example 7. Oh, weird. I drew the line by accident. This one's for you to try. The graph of y equals f of x includes the points 2, 5, 4, 15. The graph of g of x includes 2, 6, 3, 16. Which of the following must land on y equals f minus g of x? So y equals f of x minus g of x. Now you can only compare when these x's are the same, right? So if I wanted to do f of 4, y would be 15, but I don't have a g of 4. If I wanted to do g of 3, y would be 16, but I don't have an f of 4. So the only ones I can compare are the 2's. So I would do y equals f of 2 minus g of 2. F of 2 is the y. So it's f of 2 is 5 minus g of 2, which is 6. So y equals negative 1. So what point must land on there? The coordinate 2 and negative 1. And we're going to skip example 8. And that is it for sum and difference. Sorry, this one's longer, but it's a lot of learning new things. Okay? Have a good day.